Welcome! Is it getting hot in here, or is it just my imagination? This is my response to Rod Martin's 5th video in his series Global Warming Lies Exposed. That one was entitled Our Current Warmth is Unusual. So we're going to take a look and see just how unusual our current warmth is. Context is always important in these sorts of discussion. Martin asked the question, has the Earth been warmer in the past? And the answer to that is unequivocally yes. If we went back far enough, the Earth would have been a ball of molten lava with a surface temperature of over 1,000 degrees centigrade, and we could all agree that that was a lot hotter than it is today. But is that relevant? So let's go take a look at the picture that Martin actually showed us. Here is the Earth's temperature marked in blue, and the current temperature for reference is about 16 degrees centigrade, so we're somewhere in about the middle of that range. But there have been long periods in the past when the Earth has been warmer. But what was the Earth like back then such that we can draw conclusions about today? Well, let's go back 550 million years and see what the Earth looked like. Now here we have the picture of the continents back then, and it doesn't look like anything that we can recognize. Well, let's go back, say, 220 million years. Still no luck. All the continents were in different places again. 136 million years, you're beginning to see some of the things that we can recognize, but they certainly weren't in the same place. Well, 65 million years ago, looking a lot more promising, but there are still some things out of whack here. Australia is joined to Antarctica, North America is joined to Eurasia. And that's the situation today. So somewhere between 65 million years ago and today, the continents got into a similar configuration to what we now have. And so that's when the weather systems and the climate system starts becoming relevant. So let's go back to his plot and see what proportion of the plot is actually relevant to this discussion. And it's a very tiny proportion indeed. And why is that? Well, the differences are too large. As we've just seen, the position of the continents all in different places. That would affect the way that the ocean currents flow. And the ocean currents affect the weather quite significantly. In that same plot, it shows how different the atmospheric composition was back in those days. The mountain ranges would have been different. There had been different mountain ranges, much taller, much shorter, and in different places, which affect the wind patterns, and the wind patterns also affect the weather. We would have different animals and plants. And Martin himself admits that solar activity and output was different back then. So there's so many differences that you can't really draw very many specific conclusions from this past data. Now you can use it to get some of the ideas for what can affect overall climate of the Earth. You can't really apply it to day-to-day situations here and now. Next, we must determine how unusual is unusual. Now I like this plot, but you have to be a little careful with it. The left-hand side of the axis is in millions of years, and the right-hand side of the axis is in thousands of years. Now this is a plot of global temperatures over the last 500 million years. And I've put on here a red line which indicates where today's temperatures are, and you can see there are only 4 occasions in the last 2.5 million years where temperatures were equivalent to or warmer than today's. If we take it out to 2050, there's only 1 occasion in the last 3 million years that is warmer than today. And I would call that, therefore, unusual. If we go out to 2100, then it gets worse. You have to go back 5 million years to find temperatures equivalent to the temperatures that are projected for 2100. And of course the problem is that it doesn't stop in 2100. That's just when they've stopped running the models to. What happens in 200, 300, 400 years time as global warming continues? There may not be anybody around to answer that question if we don't do something about it. So what is so unusual about global warming? Global warming here is defined as the increase in the average temperature of Earth over the last 100+ years. Well, previous changes in our climate have been a result of natural forces. The sun, volcanic eruptions, changes in the Earth's orbit, changes in the Earth's orientation, and so on. Global warming is being largely caused by us. We've increased greenhouse gas emissions, increased aerosol emissions. Urbanization and poor farming practices have caused problems as well. destruction of forests, and other types of pollution. Martin goes on and on about mass extinctions in this video, so let's take a quick look at that. He shows this picture which shows the 5 major mass extinctions with red stars on this picture. He talks a lot about how temperatures were cooling during this period or just before this period, but eventually concludes that temperature had very little to do with the cause of these particular events. I found this very useful figure, which is the scientific explanation for each one of those mass extinctions. The first one was caused by rapid global cooling and falling sea levels. Now this has got a lot of possible explanations, but the one that's most commonly accepted is a falling level of carbon dioxide. The Devonian mass extinction was probably an asteroid impact which caused rapid global cooling as a result of the nuclear winter that followed that. The Permian was a result of volcanic activity which increased the levels of methane and carbon dioxide in the atmosphere, creating rapid global warming and, note, more deserts. The Triassic was similar, again increasing levels of greenhouse gases, rapid global warming and more deserts. The last one was of course an asteroid impact. So we have 2 of these that are a result of asteroid impacts. One, rapid cooling caused by a reduction of carbon dioxide, and 2 caused by rapid global warming caused by the increase in greenhouse gases in the atmosphere, which is the exact opposite explanations of what happens when you increase global temperatures to what Martin has been saying in his previous videos. So what have we learned from all of this? That mass extinctions are not the sole property of either high or low temperatures, but the rate of change of temperatures. The ability of a species to adapt to changing conditions determines whether it will survive or go extinct. If the environment is relatively stable, even dynamically so, then there's no problem. If the rate of evolution is faster than changing conditions, then we get new species, but life goes on, in fact flourishes. However, if the rate of evolution is slower than the changing conditions, then you get mass extinctions. The question is, are we already in the 6th Great Extinction? You can look at the various categories of animals and you see that their extinction rates actually have increased quite remarkably in the last couple of 100 years, well above the generally accepted background rate. However, if you look at the scale on the left, you see this is a tiny percentage of the whole, but it's concerning at least. You can look at it another way, that for example birds, 99% of birds are probably not going to go extinct anytime soon. However, 13% are threatened, and we're worried that those 13% will eventually turn into extinction candidates. Similarly for mammals, 25% of them are threatened. And worst case yet is the amphibians, which are 41% threatened. Recycling is generally good, but some sorts of recycling are not helpful. Martin is merely regurgitating old and already debunked anti-anthropogenic global warming arguments. He makes them sound more sciencey, but is just pseudoscience. He uses the old trick of mixing in a few good facts from places like Wikipedia to make the rest of it sound more believable. Unfortunately, it isn't. Look at his quoted sources. The Daily Mail. What's up with that? My goodness. And I noticed in his introduction, he wants money from you. Please avoid anybody on YouTube that asks you for money. Until next time, goodbye.